All right, guys. So we'll move on to another question in exercise 4H. Question number 10. Okay, so they say in an engineering company, factories A, B, and C are all producing thin sheets of the same type. Factory A produces 25% of the sheet. Factory B produces 45%, and the rest are produced by factory C. Okay, so you can see how the production process is divided, right? So that you're producing some kind of thin sheets, 25% of them done by factory A, 45% done by factory B, and the remaining percentage is automatically covered by factory C. I think that's clear, right? Then they say factory A, B, and C produce flawed sheets with probability 0.02, 0.07, and 0.04 respectively. So they are saying here, now these factories, they produce these sheets, but when they're producing, there is also a chance that some of the sheets are actually having some faults. So these are the probability of factory A producing a faulty sheet is 0.02. Factory B producing a faulty sheet is 0.07. Factory C producing a faulty sheet is 0.04. So they are asking you now to show this information, to represent this information in a tree diagram. Okay, so basically, you know what you should do here, right? So, in a tree diagram, the branches should be branched out in such a way that when you take a single step, the branch in a single step, the total probability must add up to 1. That's the rule. So, how do we first draw the branches? What's the first branch we need to draw? All right, guys. So first you need to draw the branches corresponding to the factories because first we take the branches considering the factories, right? So you have a factory A producing, factory B. So in this case, guys, the tree diagram has a single step has 3 branches now in the first step. Why? Because some of the production is done by factory A, another part of the production is done by factory B, another part of the production is done by factory C, and they have told you the respective probability. So factory A produces 25%, which means this factory A producing probability is 25%, factory B producing probability is 45%, and the remaining probability should go to C because in a single step, the total probability must add up to 1, right, guys? So 100% is 1, right? 100% is 100 out of 100, that's 1. So you have 25% here, you have 45% here. So what's the remaining percentage? So 45, 55, 65, that's 70. So we have 30%, right? Right, guys? So we have 30% of the production done by factory C. Okay. So this is the first part of our tree diagram. So now moving on to the next step, you have to draw the next step. So now the next step they're talking about the factories producing flawed sheets. Okay, so now you need to be a little bit cautious here because now you need to further branch out. So factory A, and you're going to branch out using factory A. So using these probabilities, how do you properly branch out? You know the total probability in a branch must add up to 1. Okay, in a step. Okay, the branches in that certain step should definitely add up to 1. Okay, so how do we how do we extend the tree diagram? How do we name the branches? All right, guys. So then they say here factory ABC produced flawed sheet with probability 0.02, 0.07, and 0.04. So, guys, you need to understand 0.02 is the probability of getting a flawed sheet from factory A. So that if that is 0.02, that corresponds to factory A getting a flawed sheet from factory A. You need to ask yourself the question, what is the remaining probability? Because if 0.02 is the probability of getting a flawed, I think you understand 1 minus 0.02, the rest of the probability. That's 0.98. So if what's that 0.98? What does it represent? So you need to understand if 0.02 is the probability of getting a flawed sheet from factory A, 1 minus 0.02 or the 0.98 is the probability that we get a good sheet because there are faulty ones and obviously most of them are good, right? Okay, so then I think you can see in a similar way, you can branch out for all 3 of them, for A, B, C, all 3. Okay, so this one is flawed, no flaws. There are flaws and no flaws. So this is it. Okay, so this happens for all three factories. All three factories, now there are faulty products and there are products that are not faulty. So in A, the probability of getting a faulty product is 0.02, which means automatically it's a good product is 0.98. Factory B producing a plot sheet that's 0.07. So 1 minus 0.07 is 0.93. The next one 0.04. So 1 minus of that 0.96. Can you guys see? So this is the complete tree diagram, and it's really important that you are able to branch it out. And as you can see, every single branch, the probability adds up to 1. Can you see this probability adds up to 1? This probability adds up to 1. This probability adds up to 1. Here, a single branch, the probability must add up to 1 in order for this to be correct. All right, guys. So this is really important. Okay, so that's the tree diagram. Moving on to part B. Find the probability that a randomly selected sheet is produced by factory B and flawed. Okay. So this is a little bit of a thinking question. They say to find the probability that a randomly selected sheet is produced by factory B and flawed. So I think you can see what's going on here, right? So you need to just select the branch, right? Along the tree diagram, you recall the probabilities must be multiplied. So produced by factory B and flawed. I think you can see this branch we need to go, right? Can you see here? Produced by factory B and it's flawed. Can you see? So that's the branch that you need to concern here. So what do? So produced by B and flawed. All you have to do is multiply the probabilities, right? 45% into 0.07. So get me the answer. 45% is 0.45 into 0.07. So we have 0. Okay, so then moving on to Roman number 2, they say to find the probability that it is flawed. Okay, so in this one, they don't specify any factory. They don't say whether it's A or B or C. They just say flawed. So when they just say flawed, you can see you have 3 options. So you have A and flawed, B and flawed, it's C and flawed. There are three possible branches. So along the branch, probabilities are multiplied, and different branches probabilities must be added. Right, guys? So these are some simple theories you have learned previously as well, right? Okay, along the branch, probabilities are multiplied. So I'll multiply 25% into 0.02 plus the next one, factory B. So this is concerning A. So B, factory B, 45% and flawed is 0.07. Can you guys see what I'm doing? Plus next going to factory C. Produces, so that's 30% into the flawed probability 0.04. All right, guys. So along the branch, there are 3 branches where you get flaws. There are 3 possible branches that gives you flaws. So what you need to do is you get the probability of each of those branches and add them. Okay, so probability along the branch is found by multiplying, right? So this is A, getting a faulty product from A. This is the getting a faulty product from B, and this is getting a faulty product from C. Okay, so get the answer. All right, guys, over here, I think there was a slight error, right? So this probability, multiplication probability is 0.0315 or 3.15%, right? So there was a slight multiplication error here. All right. Okay, so moving on to part C. Okay, so sorry. So over here, I'm sorry. The probability, I hope you guys got this answer as well, right? So all you have to do is to multiply these 3 values and, get the answer. So that's a small part. Okay, and we fix the answer in B part 1. Okay, right. So moving on to part C, they say given that, okay, guys, so there's a special word here. Can you see? They use the word given that. Okay, given that a randomly selected sheet is flawed. So they are telling you that the sheet is flawed. Find the probability that it was produced by factory A. So guys, this is something that's really important. You need to understand I think you remember we were discussing in detail about something called conditional probability. So in conditional probability, you don't take everything, right? You only take the from that given that set, because given that is the thing that has already happened. So over here, given that a randomly selected sheet is flawed, which means what? Which means I hope you guys remember conditional probability work like this, right? So A given B, right? Do you recall probability A given B, right? So probability A given B. So I think we gave the rule, right? So guys, so this is the conditional probability rule. Do you recall? So we did this previously. So I explained this to you how this works. Probability of A given B. So guys, the one we write behind the slash is the given probability. So then what we do here is, I think we use this a lot. And so you should have some good experience in using this now, right? So how does it work out? The total probability is now not out of one. The total probability is taken from the given that. If you recall how we did this, right? The total probability is from the given that part, and then we write on top, we write the probability where A and B both work together. Do you recall? So we get the probability of A happening inside B. If you remember the Venn diagram and the two-way tables, that's how it worked, right? So I think I explained this a lot, so I'm not going to go into that part again. So let's just quickly go for the answer. So given that part should come behind, and find whatever the probability of finding, that part comes to the front. So they say here, given that a randomly selected sheet is flawed. So given that is it's flawed. So basically, guys, the this B event B is that it is flawed. Find the probability. So find the probability is what you are interested, what you need to find. Find the probability it was produced by factory A. So guys, when you're writing this should be written as well. So the first one, find the probability. The finding part should come at the front. So produced by factory A, given that the given that part is it is flawed. Can you guys see how to write this? So it they have told you the, the the particular product is flawed, and you have to find the probability that it is from factory A. So how do you open this? Probability A and flawed. A intersection flawed means A produced by factory A and it's flawed, divide by the probability of flawed. You guys with me? Okay, so that's how you exactly open this. Okay, so probability of A and flawed. So this is the probability of being flawed and being produced by factory A. So what is that? A and flawed is, guys, you can, as you should see, it's this branch, right? So this is the probability of getting flawed from A, because it's A intersection flawed. A intersection flawed means this branch, right, guys? So you need to understand this is the branch for A intersection flawed. Okay. So that's going to be 25% into 0.02. Divide by probability of flawed. So what's the probability of flawed? I think you saw, we found it, right? The probability of flawed means you have to get the total probability of getting a flawed. So that we have already found. 0.0485. All right, guys. And then you can get the answer for this, which gives you the probability of getting a flawed product from factory A. Given that the product is flawed, so the chance that we get it from factory A. So get the answer. Right, guys. So the answer is 0.103. All right. So this is kind of like the base foundation that you need to know in order to, work with tree diagrams, but you will definitely find more complicated, more advanced, tree diagrams when it comes to the exam. Okay. So we'll go through those questions in the next part as well. Okay.